Binomial Theorem Combination Method.
Okay, so this is Binomial Theorem Lesson 2 under Wassce Concept by King Solomon. And today I'll be looking at the combination method. The combination method. So in math, we have what we call permutation and combination. Permutation and combination. So anytime you hear the word, and maybe let's say n permutation r, it simply means n factorial or divided by n minus r factorial times r. But anytime you hear the word n combination r, it can also be represented as n combination r. So you can either see it this way or you see it this way. It is simply n factorial divided by n minus r factorial r factorial. So you realize that with combination, the r has no, it's not a factorial. But in permutation, the r is not a factorial, but in combination, the r is a factorial. So you should put this in your head. I'm not doing permutation, but I'm doing combination, but I want to know the difference between. So now we are going to use this method, the combination idea, to also expand a given term. So if you have a term, for instance, like a plus x exponent n, we are going to use the combination idea method to expand this term, no matter how long it is. Okay, so now let's look at it. Okay, so let's look at it here. Now, I already said that the combination, n combination r, can also be written as n combination r. Okay, so now since it's the same, if you have an expansive term like ax exponent n, and you are asked to expand it using the combination method, what is the formula? So first of all, you start by n combination 0 multiplying a times n plus n combination 1. So now what happens is that you'll be increasing from 0, the 0 term, till you get to the n term. So n combination 1, a n minus 1. So it's more or less like the a part is more or less taking the what do you call, the binomial theorem formula we did in the first video or in the lecture 1. So you get that, yes, x1 plus n combination 2 a exponent n minus 2 x2, and it continues till you get to n combination n. Sorry, n combination n a n combination n exponent x n. I get it. So you continue till you get to n combination n till x exponent n. Okay. Now, let's take a particular example. Or that is to say, if you have a x exponent n, then it's simply the summation of all the n variables starting from 0. The summation of all the n variables starting from 0, n combination r, a n minus r, x exponent r. So anytime you have a plus x exponent n, then it's the summation of all n values starting from a value r, which is equal to 0. N combination r, a n minus r, x exponent r. Now let's take a typical example, and let's look at how we can go about it. So now, for example, we have to expand 4 plus 2x exponent 4. So we have to expand 4 plus 2x exponent 4. How do you go about this? Expanding 4 plus 2x exponent 4. So now we come here, 4 plus 2x exponent 4. It is an identity to a plus x exponent n. So therefore, from here you can say that a is 4, x is 2x, and n is equal to 4. So if we have this, then it's good for us to go. So now we can start n combination 0. So we can start n combination 0, which is 4. So n is 4. So therefore, 4 combination 0. What is a? A is 4 exponent n. N is 4 exponent 4. Plus n combination 1. So what is n? That is 4. 4 combination 1 a n minus 1, that is 4. What is n minus 1? Exponent 3. And the x exponent 1. And x is what? 2x exponent 1. Okay. Plus. So when you continue this way you're getting 4 combination 2. 4 exponent, so it's reducing. So you get 2x squared plus 4 combination 3. 4 is reducing, so it's 1 now. 2x exponent. This is 2x exponent 2, so this is exponent 3. Okay. And the last one plus 4 exponent 4 combination 4. 4 exponent 0. 2x exponent 4. So you are done. Because you have to get to the n exponent n itself. So that's 4 exponent 4. The a is 4 and it's reducing. And that's 0. 2x exponent 1. As a matter of fact, when you get to the n exponent n, you don't even bring the a because there will be no a. It's only the x part. So let's put the x part over there, which is 2x exponent 4. So now when you do this is what you'll be getting. Now, you know that the 4 combination 0 here. 4 combination 0 here simple means that 4 factorial divided by 4 minus 0 factorial, 0 factorial. I get it because you said the n combination r simple means n factorial divided by n minus r factorial, r factorial. So that's why you'll be punching on your calculator. It is on your calculator. If you want to punch for combination 0, for instance, let me teach you on the calculator. So this is your calculator. If you want to punch for exponent 0, so you come here, you punch your 4, yeah, and you press your shift button, and this is the combination. That is on the division so you press your combination, this is what you'll be getting. And let's say if the 4 combination 3 is what you want, you press your 3, and that's it. So this is what you'll be getting. So pressing your 2, you press your equal to button, and you get your answer, and that will give you 4. Yeah, so that's how we do it. So it's always the number, you press your shift and the division sign, and you press the other number. So this is how we go about with the combination. Okay, so with that said, then you can simplify this one. So 4 combination 0 times 4 exponent 4. 4 combination 1 times 4 exponent 3 times 2 exponent 2x exponent 1. So when you do this is what you are getting. You are getting 1024 plus 2560 x plus 2560 x squared plus 1280 sp plus 320 x exponent 4. So when you expand this is what you are getting. This is what you are getting. Now there's a typical example I want us to look at. There's a typical example I want us to look at. There's a typical example I want us to look at over here. And this example, the example says we should expand yeah. Okay, so this example. So the question says that we should expand 1.002 exponent 4. So the question I given to us that we should expand 1.002 exponent 4. Now you can easily punch it on the calculator and you get the answer. And when you punch it on the calculator, you'll be getting 1.008024032. So when you punch on the calculator, this is the answer you'll be getting. But now the unit to us that we should use the procedure to solve it by the combination method. What do? You have to use the same idea here. But what happens is that 1.002 exponent 4 can be extended as 1 plus 0.002 exponent 4. Now 1 plus 0.002 is the same as 1.002. So now when you do this, what happens here is that what happens here is that we can now say that a plus x is equal to n, where a plus x is equal to n, where our a now is equal to 1, and our x is equal to 0.002, and our n becomes 4. Anytime you have a to be equal to 1, that is to say 1 plus x exponent n, there's a new expansion you can easily go about by the combination method. And the expansion says that, first of all, n combination 0 and 1 exponent n plus n combination 1, 1 exponent n minus 1, x plus n combination 2, 1 exponent n minus 3, x squared plus n combination n, x exponent n. So now, anytime you have the a being equal to 1, you can easily go by this expansion. You can easily go by this expansion. So now, how do we expand this? It is very simple here. N is 4, a is 1, x is 0.002. So now, 1.002 exponent 4. Expanding will now be equal to n, which is equal to 4. 4 exponent 0 and 1 exponent what? 4. Plus 4 combination 1 times 1, that's n minus 1, which will give what? 3. And x. And the x value there is what? 0.002 exponent what? 1. Plus 4 combination 2. 4 combination 2, 1 exponent 2, and x, which is 0.002 squared. The x is also increasing. Plus 4 combination 3, 1 exponent 3, so 1 exponent 1. And the x, which will increase, 0.002 p. And the last one is plus 4 combination 4. And you get 1 exponent 0, and the x value, which is 0.002, right, exponent 4. So now when you do this expansion, that is by this idea, binomial theorem idea, 1.002 exponent 4, this is what you'll be getting. From the first instance, you get 1 plus, when you do this analysis, you get 0.008 plus, when you operate on these two, you'll be getting 0.000024 plus, when you operate on this, you are getting 0.000000001, 2, 3, 4, 5, 6, 7, 8, 0, 2, 3, 2, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So 3, 2. Okay. And when you do the last one too, you're getting 0.000000000 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 6. Okay, so now that in simple, it will give 1.6 times 10 to the power negative 11. This one will give 3.2 times 10 to the power negative 8. This one is 2.4 times 10 to the power 5, negative 5. Yeah, that's it. Now, when you sum everything together, you are getting 1.008024032. And that is the same answer as you punching on the calculator. That is the same answer as you punching on the calculator. So let's see it on the calculator. So now, this is what you get when you punch the question on the calculator. So you realize that that is the same answer, 1.008024032. Okay. Thank you for joining.